In this video, I am going to be determining the differences between a weak base strong nucleophile, weak base weak nucleophile, strong base strong nucleophile, aka WBSN, WBWN, and SBSN. The differences between these are going to be very important for determining the differences between SN1, SN2, E1, and E2 reactions and what reaction to do when you see these, and the substrate factor as well. So the easiest list here to remember, in my opinion, would be the WBWN, because that is going to be neutral water, H2O, or neutral alcohol, ROH, where R is any random alkyl chain like the ethyl group ethanol or methyl group methanol, right? You might also see a neutral carboxylic acid like that, but these weak base weak nucleophiles here are going to be used for SN1 and E1 reactions in substrates that are secondary or tertiary, because there is a carbocation that gets formed, and we prefer a more stable carbocation, which is going to be secondary or tertiary. So the next list is going to be strong base strong nucleophile, and a way that you can remember that is if you see a negative charge on an oxygen or a negative charge on a nitrogen, right? So some examples would be OH minus, OR minus, NH2 minus, and those would be strong bases strong nucleophiles. But there's two types, right? There's a small or unhindered type, and there's a bulky or hindered type, where the small unhindered type is going to look something like this, where this carbon here directly attached to the oxygen is only attached to one branch, right? But when we have this carbon here that is attached to the oxygen attached to more than one branch, then that is considered a bulky base, which is going to lead to the Hofmann E2 reaction, whereas the unbulky or unhindered base is going to lead for the Zaitsev E2 reaction, right? So another bulky base that you might see is LDA. So those are going to be your E2 reagents with the SBSN. So for the WBWN, that's everything else, like CN minus, N3 minus, sometimes neutral amines, SH minus, everything else that is not a WBWN or SBSN. So what I recommend is to know the WBWN and SBSN and the different types of it really well, and then everything else you could bet that it would be a WBSN, which is going to do an SN2 reaction, which would prefer to attack less substituted substrates like primary or methyl substrates. Sometimes secondary would work, because we need less steric hindrance in order for the nucleophile to reach the electrophile and attack on the backside and invert stereochemistry.